Just as every student of mathematics is special, we're going to look at special products. Unique things we can do with products of binomials. Two of the special ones are the squares of sums and differences, which we will really want to be familiar with, and the product of a sum and a difference is also great for the next chapter. We're going to start undoing this with a process called factoring. Something special happens every time we multiply a binomial by itself. Let's look at our FOILing again. So there's our first, outer, inner, last. So it seems to be these two came out to be the same for some unknown reason. And let's look at another one. Let's get one with subtraction. So how about x? Let's just do -2. So what we're doing, that's really x minus 2 squared. We're multiplying it by itself. So when we FOIL that out, first, outer, inner, last. And combining our likes. Okay, again, I can see these two numbers are always going to be the same. So this number ends up being the double of that product. And there's also something special about this guy. We took -2 times -2, or squared -2, to get a +4. And same thing on the first problem. We took 3 times 3, or 3 squared, to get the 9. So this gives us a general pattern for the square of a sum. Every time we square a binomial, it is always going to be the square of the first term, in this case a, plus twice the product of a and b, so twice the product of the first and the second term, and then plus the square of b. So it's always first term squared plus first term times the second term times 2, and then it's always plus the second term squared. So to square x plus 7, we could write it out and FOIL it, or we can just use the pattern. So the pattern is preferable, so it's always first term squared, so x squared, first term second times 2, so 2x times 7, plus second term squared, so plus 7 squared, and voila, there's our quick final answer. So we're going to start off with first term squared, so 7z, just square that, plus 2 times first times second, which happens to be a 2, plus the second term squared. So our final answer, and we're done, is going to be 49z squared, plus 14 times 2 would be 28z, plus 4, quick and easy. Same pattern, first term squared, plus 2 times first times second, plus second term squared. So we have 25q squared plus, 10 times 9, that's nice, 90, qr, I almost lost my q, plus 81 r squared. And that's all she wrote. Now the only difference if our binomial is subtraction instead of addition, and I kind of ran through this with numbers, is our sign is going to be negative here. In my mind, one pattern works for both because it's still first term squared, first times second times 2. It happens to be the second term when you do the product will be negative. And second term squared, which will make negative times a negative, is always a positive, so it's the same thing. So once again, we have the first term squared plus first times second times 2 plus the second term squared. And if you keep your signs in your parentheses, it comes out perfectly. I have 9c squared. Positive times positive is positive, times negative is negative. So 6 times 4 is 24c. And negative times negative is going to be plus 16. And that's all she wrote. Here comes our pattern again. First term squared plus double our first times second, so 6c negative 6f, plus second term squared. So we're going to have 36e squared minus 72ef minus, oops, negative times negative is positive, my bad, 36f squared. And they're very quick problems. Here we go again with a geometry connection. Write an expression that represents the area of a square that has a side length of 2x plus 12 units. I'm going to do it again. I'm going to call that meters. Give it a real name. Okay, we know how to find the area of a square. If we know the length of a side, we're going to square it. So the length of our side is 2x plus 12, so we need to square it. When we square a binomial, our pattern is first term squared plus 2 times first times second plus second term, you named it, squared. So first term squared is going to be 4x squared plus 48x plus 144. And we're done. Other than, I called it meters, so area is going to be meters squared. Something special is going to happen here. If we do our FOILing, we have first x squared plus 3x, outer, and now inner, minus 3x, last, minus 9. So magically, no, it's not magic, it's mathematics, the middle terms drop out, and we have something called difference of squares. Difference is the answer when we subtract, and these are both perfect squares. Now we'll use the term difference of squares when we're going the other direction when we're factoring, but it doesn't hurt to throw it in here. So if we have the product of a plus b and a minus b, that middle term always drops out, so all we're going to have is a squared minus b squared. Or if it's x plus 9x minus 9, our final solution is going to be x squared minus 81, and you're done. So this goes very quickly. If we took the time to FOIL, we'd have 81 d squared plus 36d minus 36d minus 16, like terms, well, actually additive inverses, they canceled out, so we have 81d squared minus 16, which is going to work every time we've got the exact same terms, just with a plus and a minus between them. So I'm going to do this using the shortcut. It is 10g plus 13h cubed, 10g minus 13h cubed, so it is our difference of squares pattern. So I'm going to have 10 times 10 is 100, g times g is g squared, minus 169, h to the power times the power, we add exponents, so it's going to be to the 6th. So the only time when we multiply two binomials that we end up with a binomial is in this situation where the middle term cancels out. So here are our special products once again. The square of a sum, we're going to have first term squared plus 2 times first times second plus second term squared. For a difference, it's the same thing. First term squared happens to end up being a minus because of the negative sign with the b there. 2 times first times second plus, again, b squared. And our last one that we just did, if we have a plus b times a minus b, either way you switch it, we're going to end up without a middle term, so it only has two terms. It's a squared minus b squared.